Here we are going to solve for this non-homogeneous higher order equation, but specifically the process that involves the Wronskian of functions. One of the reasons is that this g of x here is not found on our trial of particular solution when we solve for same non-homogeneous higher order equations using the y sub p with the table. That is why the y sub p here is expressed in this formula. Nevertheless, the solution is still the total of y sub c and y sub p. And again, y sub c is when this g of x is equal to 0 to come up with our auxiliary equation to determine the general or complementary solution. And after that, we'll also be able to identify certain y sub 1 and y sub 2 on our general solution for y sub c, which are also to be used for our y sub p. It's just that we need to solve for u sub 1 and u sub 2 using the concept of Wronskian going up. So for this, let's try to start with y sub c. We have here f of dy equal to 0. You will have d squared plus 3d plus 2 times y is equal to 0. Hence, our auxiliary equation would be m squared plus 3m plus 2 equal to 0. We can factor this. You can have m plus 1 and m plus 2. You can have that. Therefore, you will have here a result with your first root is equal to negative 1 and your second root is equal to negative 2. So these are the roots of our given auxiliary equation, and with that, we're able to identify that our roots are both real and they are distinct from one another, or they are different. With this, we are going to use the general solution for our y sub c when we have roots of our auxiliary equation being distinct and real. So we will have here c sub 1 e to the power of m sub 1x plus c sub 2 e to the power of m sub 2x. Take note that you can always interchange your roots, but nevertheless, just plugging in this just for this purpose, you have c sub 1 e to the power of negative x or negative 1x plus c sub 2 e to the power of negative 2x. This is our y sub c, the first part of our solution. Together with this is the identification of our y sub 1 and y sub 2, which are important in solving y sub p. But let's look into the w first, the Wronskian. We are also going to use the same y sub 1 and y sub 2 for our Wronskian e to the power of negative x and e to the power of negative 2x. Now, we were able to identify already the Wronskian of this given item. And if you are not yet convinced with the answer that I'm going to place here, you can always use the previous video. You can check on the link below, because we're able to identify already the Wronskian of this in that video, together with the discussion as to how do we're able to solve the specific values. And because Wronskian is just the determinant of a certain matrix. And by the way, speaking of matrix, we are also going to present here the same matrix because it will be used for our w sub 1 and w sub 2. The Wronskian of these two functions is negative e to the power of negative 3x. That's the Wronskian. Again, the video is already provided below. You might want to check the process involved there to solve for this said Wronskian. Okay, this is the matrix we use to solve for this Wronskian. We have e to the power of negative x, e to the power of negative 2x. The second row will just be the derivative of the first entries on the first row. So you will have here itself times negative 1. And here, negative 1 is the derivative of the exponent. So if e to the power of negative 2x times negative 2, the derivative of the exponent as well. So we'll have this matrix, e to the power of negative x, e to the power of negative 2x. You have the negative of e to the power of negative x and the negative of 2 e to the power of negative 2x. The Wronskian is just a determinant of this. That is why we're able to solve for negative e to the power of negative 3x. Okay, that's the Wronskian, considering that our y sub 1 is e to the power of negative 1 and our y sub 2 is e to the power of negative 2x. Okay, so this will also be used in solving for w sub 1, because w sub 1 here will allow us to come up with our first column, 0, as the first entry, and the last entry would be the given item here, the given g of x. So it's just sine of e to the power of x. But the second row will just be the second row, similar here, negative 2 e to the power of negative 2x. Okay, for our w sub 2, it will be the second row having the same entries as this column. Okay, and the first column would be the same here, e to the power of negative x, negative e to the power of negative x. Okay, so solving for w sub 1, w sub 2 follows the same idea of the Wronskian. So you will have here this product here, so that's actually just 0, and then to be subtracted by this result. So minus sine e to the power of x times e to the power of negative 2x. Take note, this is not to be multiplied with that because that's the angle of sine. So the final form is just simply negative, you can start with e to the power of negative 2x sine e to the power of x, so that you will not be confused with the two. Okay, then we are going to proceed with the second. So multiplying this, you will have e to the power of negative x sine e to the power of x, then minus this region 0. Okay, so minus 0, leaving us with the result of e to the power of negative x and sine e to the power of x. Okay, so with this two in mind, we can now proceed with our solution, the continuation of our solution here. Because looking into the w, you can get your this one here, u prime sub 1 and u prime sub 2 as the ratio of w sub 1 over w and w sub 2 over w respectively. And this would be the first step in solving for the u sub 1 and u sub 2 to be paired with the y sub 1 and y sub 2 here, just for your y sub b. So let's start with u prime sub 1 is equal to w sub 1 over w. Your w sub 1 is w sub 1 is this. So you have here negative e to the power of negative 2x sine of e to the power of x over this, okay, negative e to the power of negative 3x. So take note of the exponents there, but basically this is positive now, and you will have a negative on the bottom. Or you could, of course, you could always bring this up. Once you bring that up, it will become e to the power of positive 3x. Then you can combine them, adding exponents. You will get a positive x now. So e to the power of x now, sine of e to the power of x. Okay, that would be your first value for your w sub 1. This is because you're actually, again, negative and negative, that's positive. You're moving that up, positive 3x, and you add exponents, you will have that. Okay, that's for your w sub 1. For your, this is your u prime sub 1. U prime sub 2 is w sub 2 over w. You will have e to the power of negative x sine e to the power of x all over negative e to the power of negative 3x. So same thing, you can bring this up. You will have your e to the power of 3x, and when you combine that, you will get a result of negative e to the power of positive 2x sine of e to the power of x. These are your results. So let me just remove, let me copy this and move to the next page, because I have also provided here or prepared another page. So please bear with me. This page as well contains already this additional formulas, and let me remove these notations. Alright, so the next thing here is to come up with our u sub 1 and u sub 2, which will be integrated or integrating these two here. So your u sub 1 is the integral of u prime sub 1, and we are going to add here dx, okay, as our x is our variable, and we need that because we cannot integrate without dx. So you will have here the integral of e to the power of x and then sine e to the power of x dx. Okay, now look into this. Consider this as our first function, sine e to the power of x, and you will have here e to the power of x dx. This could be sine of u du. This is our u, and its derivative is e to the x dx. So we don't need to add anything there. That's already okay, and we simply proceed with the derivative integral of sine e to the power of x, and the integral of that is actually negative cosine e to the power of x. Okay, that's the first value. That's our u sub 1. For our u sub 2, you will have here the integral of u prime sub 2. So you will have here the integral of this one here, negative e to the power of 2x, and then sine e to the power of x dx. Okay, let's apply here integration by parts, because we cannot separate. We can have this one negative. You can have here sine e to the power of x, e to the power of x dx for your just like what happened here earlier, but you will have an additional e to the power of x here because this is twice x. That means we have another e to the power of x. So what I would like you to do here is this. Of course, integration by parts. Your integral of u dv is equal to uv minus the integral of v du. Let's say u being e to the power of x. So our du is e to the power of x dx. Okay? Again, we're moving out the negative sign outside. That would mean if I'm taking one of the e to the power of x here, I still have one more e to the power of x. So our dv is sine e to the power of x and your additional e to the power of x dx. And the integral of that, dv, is the integral of this sine e to the power of x, e to the power of x dx. So that, no worries, that's just negative cosine e to the power of x. Okay? So with this, okay, please bear with me. So you will have here the negative. Again, we're taking out negative first here. Please don't forget that. Integral of, sorry, it's no longer integral. The negative of uv, u, e to the power of x, and your v is negative cosine e to the power of x, minus the integral of v, negative cosine e to the power of x du. This is our du. E to the power of x dx. Okay? Now, negative of negative e to the power of x cosine e to the power of x, minus, or we move negative here, so plus the integral of cosine e to the power of x, e to the power of x dx, which is just equal to negative e to the power of x cosine e to the power of x plus sine. That's simply sine e to the power of x. So moving out, removing the negative, this is our u sub 2, okay? So you have positive e to the power of x cosine e to the power of x plus minus, okay, minus sine e to the power of x. That's our u sub 2. Our u sub 1 is already identified here. Okay, so I still need one more page. Okay, so we have one more page. Let me copy the same formulas because we're almost there. Copy, paste it here. Then I will write here u sub 1. Our u sub 1 is actually negative cosine e to the power of x, e to the power of x, and our u sub 2 is this one here. Let me copy this. Okay, copy, paste, but let me erase this. Okay, Now, our y sub p is just equal to u sub 1 y sub 1 plus u sub 2 y sub 2. So simply multiply them. And by the way, don't forget that our y sub 1 is e to the power of negative x and y sub 2 is e to the power of negative 2x. Let me also write it here. Y sub 1 is e to the power of negative x. Y sub 2 is e to the power of negative 2x. By the way, if there are chances where you interchange this, some of our solutions will also be interchanged because the w sub 1 and w sub 2 together with the Wronskian will also be changed. Okay? So with that, y sub p, u sub 1 is negative cosine e to the power of x times e to the power of negative x. Then plus u sub 2 is e to the power of negative 2x times the binomial expression e to the power of x cosine e to the power of x minus sine e to the power of x. So you have negative e to the power of negative x cosine e to the power of x. Then this you will have plus, take note, you have the same base, so you have e to the power of negative x cosine e to the power of x. Okay, then multiplying that here minus e to the power of negative 2x sine of e to the power of x. Looking into this and that, you have cosine, cosine, negative, positive. So y sub p is simply this result here. Okay, negative e to the power of 2x, negative 2x sine of e to the power of x. Okay, so our y sub c, y is equal to y sub c plus y sub p. Our y sub c, where was it? So y sub c here. Okay, so y sub c is c sub 1 e to the power of negative x plus c sub 2 e to the power of negative 2x, and then minus e to the power of negative 2x sine e to the power of x. This is now our solution for the given equation. So again, we have a lot of steps to consider together with the correct signs. We need to follow all of those because once we forget some of this process, then we cannot show the final answer to this one. Thank you very much for watching.